Hello, in this video we're going to extend our conversation about sequences. We're going to talk about arithmetic sequences. So we're going to start with a problem here. A wooden post and rail fence with two rails is made as shown below. Find the number of pieces of wood needed to build a 4-section fence, a 5-section fence, and a 6-section fence. Suppose you want to build a fence with 3 rails. How many pieces of wood are needed for each size fence? Describe the pattern. As you can see, the number of pieces of wood used for one section of the fence or 2 sections of the fence and so on form a pattern or a sequence. As you can see down here, 4 pieces, 7 pieces, 10 pieces. A sequence is an ordered list of numbers that often form a pattern. Each number in the list is called a term of a sequence. When you can identify a pattern in a sequence, you can use it to extend the sequence. You can also model some sequences with a function rule that you can use to find any term of the sequence. So we'll get back to this question. So here we're going to work on extending these two sequences. So as you can see, we go from 5 to 8 to 11 to 14. It's probably pretty simple to see that we're just adding 3 to each term here to get to the next term. And so to extend this sequence, it's probably relatively simple. We're going to add 3 to get to 17, and then we're going to add 3 to get to 20, and so on. This sequence down here, let's take a look. So to go from 2.5 to 5, well, we could add 2.5. So, and then to go from 5 to 10, we could try adding 2.5, but that didn't work. All right, so that's not correct. So to get to the next number in a sequence is not always addition. So now we're going to have to try some other operation here. Well, from 2.5 to 5, we could multiply by 2. From 5 to 10 is multiplication by 2. From 10 to 20 is multiplication by 2. So we can assume that the next number will be 40, and that the next number will be 80. In an arithmetic sequence, the difference between consecutive terms is constant. This difference is called the common difference. So here, this is an arithmetic sequence because the difference between the terms is constant, always a difference of 3. So the common difference is just 3 in each of these cases. So let's take a look at a couple new ones. So if we were given this sequence here, 3, 8, 13, 18, we need to find out, is this arithmetic? And again, if the sequence is arithmetic, the difference between the terms is always the same. So 3 to 8, that's a difference of 5, and then 8 to 13 is a difference of 5, and 13 to 18 is a difference of 5. So we can say that yes, it is arithmetic, and if it is arithmetic, the common difference, or we should get an answer for the common difference, which in this case will be 5. Let's look at number 2. From 6 to 9, that's plus 3. From 9 to 13, that's plus 4. From 13 to 17, that's plus 4. So is this an arithmetic sequence? The answer is no, because the common difference is not the same every time. So there is no common difference. So now we're going to try to write a recursive formula. And what a recursive formula does is it's kind of what you guys have done before. You just didn't know it was called a recursive formula. So we know these are all plus 7, plus 7, plus 7. So a recursive formula relates the next number in the sequence to the previous number. For instance, we'll call, if we say n equals the term number in the sequence, term number, so what we can do, I'm going to move all this over here. Alright, so we're going to call this n. I'm going to make a little table here. There we go. It's a messy table, but table nonetheless. So this will be the first term, second term, third term, fourth term, and we could keep going there. And then we'll call this a to the n, and that is the value of the nth term. So the first term has a value of 70, the second term has a value of 77, and so on. So the value of term 1 we can write as a to the 1. Right? The value of a to the 1, so and when n equals 1, the value of a to the 1 is 70. The value of term 2, which we can call a2, is going to be a1, or 70 in this case, plus 7 to get to 77. And the value of a3 is the value of a2, which was 77, plus 7. And then we get to 84. And so on. So I'll do one more here. A to the fourth, or not a to the fourth, I'm sorry. The value of the fourth term is the value of the third term plus 7, which is 91. The downside of this recursive formula is if we want to find out what the value of the 100th term is, we have to write this out 100 times. Nevertheless, it still has some value, but I'm going to show you a way to write a function rule rather than a recursive formula next. So the way we write the recursive formula is the value of the nth term is equal to the value of the previous term plus the common difference, which in this case is 7. So the value of the nth term, so like the 100th term or the 50th term, is equal to the value of the previous term plus the common difference. So if we wanted to find the value of the 8th term, for instance, we would need to find the value of the 5th term. So that would be, what are we at? 91 plus 7, which would equal 98. The value of the 6th term, which would be 98 plus 7, which would be 105. Value of the 7th term, which is 105 plus 7, which is 112. And finally, we would get to the value of the 8th term, which is 112 plus 8, which is 120. Okay, so we definitely want a faster way to do that. And the faster way to do that is to write an explicit formula. Now, an explicit formula is an equation where you do not have to have the previous term value to get the current term value. 200, 210, 220, 230. And then just like in the previous example where I made this table here, we're going to label the terms, the nth terms, and label the values. So we'll call this term 1, term 2, term 3, term 4, sorry. And make a little table. Oops, I need one more box here. There we go. So this is n, and this is the value of the nth term. And here's the formula that we're going to use to make our explicit formula. So the value of whatever term we want to find, a to the n, is going to equal the value of the first term, that's a to the 1, the value of the first term, 200 in this case, plus n minus 1, which is just the term before the term that we want to find. So n minus 1 times the common difference. In this case, the common difference is 10, 10, 10, so times 10. And so now we can clean it up a little bit. So we have equals 200 plus 10n minus 10. So the formula for a to the n is, we're going to put the variable term first, so 10n, and then 200 minus 10 is 190 plus 190. All right. And so we'll get some practice with this tomorrow, but it actually will turn out to be pretty simple. There is a section in the book here that talks about writing an explicit formula from a recursive formula. I don't think that's totally necessary because from your recursive formula, you can come up with these values anyway and then make your explicit formula. So you don't really need to use the recursive formula because you could just use the values of it. And I think this will just get you to start memorizing things and not kind of pay attention to what's going on. And also there's a section on writing a recursive formula from an explicit. Same thing here. If you had the explicit formula, you could write out the values and then make a recursive formula on your own from what we have learned previously. So rather than memorize this, I'd rather have you just kind of think through it. And then once you get more practice with it, we can go on to some formula here. And that's it for the video. Thanks for watching.